Hello math learners! We have already discussed the introduction, the overview, and the terms related to circles. Today, we're going to discuss the relationship of arcs and chords. This is still part of the discussion on circles. In this video, you will also know the theorems behind their relationship as well as solve problems about it. But before anything else, hit the subscribe button and notification bell for you to be updated of these cool clear math videos just like this. Hello math learners! Welcome to another session here in Math Learning with Sir Ash. This is still your free access math teacher Ash, and today we're going to discuss the most essential learning competency-based lesson for quarter 2 of the grade 10 mathematics, which is all about arcs and chords. Now the question is, what is an arc and what is a chord? An arc is basically a part of the circumference of a circle. A chord is a line segment in which the two endpoints is part of the circle. The next question is, what is or are the relationship of arcs and chords? In geometry, there are theorems that are being presented for us to consider the relationship of the arcs and chords. Question, what is a theorem? A theorem is a statement that can be demonstrated to be true by acceptable mathematical operations and arguments. Now, the question is, what are the theorems behind the arcs and chords? We have two theorems to be discussed in this session. Theorem number 1 states that in the same circle or in two congruent circles, congruent arcs have also congruent chords, or vice versa. Congruent chords have also congruent arcs. For example, let's consider this first figure. If this chord is 3 cm and this chord is also 3 cm, then we can say that this arc is also congruent to this arc. Let's say if this is 78 degrees, then this is also 78 degrees. Thus, we can say that if this arc is equal to this arc, then the chords are also congruent. Very simple, right? Now, for theorem number 2. Theorem number 2 states that if a radius or a diameter is perpendicular to a chord, then the chord is bisected and the arcs are congruent with the same endpoint. What do I mean by that? If we have this figure, this is a diameter, right? And this is a chord. Let's say that this diameter and this chord are perpendicular with each other, meaning that the intersection forms a 90-degree angle. Thus, we can say that the length of this part of the chord is also equal to this part of the chord. Of course, this arc is also equal to this arc with the same endpoint on this part. Easy, right? Now, for you to understand the whole concept of this one, let's put some examples and let's try to solve it. Okay, math learners, we have here 4 different examples and we will try to solve them basing on the theorems that we have discussed earlier. Now, for the first example, we have here circle O with the points A, B, C, and D on the circle. Now, as you can see, we have two chords here that are congruent. And then, we have an arc that is 80 degrees, arc AB is 80 degrees, and arc CD is 5x. Question is, what is the measurement of arc CD? Now, basically, in theorem number 1, if we apply it in our given problem, we could immediately solve the arc CD, and that is 80 degrees. Because, as stated in theorem 1, if you have congruent chords, then the intercepted arcs are also congruent. Since this is 80 degrees, therefore, the CD is also 80 degrees. Now, the next question is, what if you are owed to find the value of x? How do you do that? Since arc CD and arc AB are congruent, then you could just put this one into a mathematical sentence like this. Arc CD is equal to arc AB. Then, this is 80 and this is 5x. If you solve the value of x by dividing 5 from both sides, then you will have a value of x as 16. Because 16 times 5 is 80. So therefore, the value of x is 16. Easy, right? Now, let's go to the second example. We have here an application of the second theorem. So this is circle J, in which diameter IH is perpendicular to chord EG. Question is, if arc HG is 8x minus 5 degrees and arc EH is equal to 3x plus 10 degrees, then the question is, what is the actual measurement of arc HG and arc EH? Okay, so remember in theorem number 2 that if you have a remember in theorem number 2 that when your diameter and your chord is perpendicular with each other, it bisects the given chord. So, in that case, the intercepted arc is also bisected. So, therefore, we can equate arc HG to arc EH. So, by doing so, we can just have 8x minus 5 is equal to 3x plus 10. Now, solving the value of x, it will become 8x minus 3x and then positive 5 plus 10, giving you 5x is equal to 15. If you divide both sides by 5, then your x is equal to 3. Now, did we answer the problem? Not yet. Why? Because we need to get the actual value of our arcs HG and EH. So what we will do is this value of x, that is 3, it will be substituted to your expression 8x minus 5, and that will give you 8 times 3, that is 24. 24 minus 5, and that will give you 19 degrees. So HG is 19 degrees. Of course, since they are congruent with each other, then this is also 19 degrees. Okay? So, if you want to use this second expression, you can do so. So, that is 3 times 3, because that is 3x. 3 times 3 is 9. 9 plus 10, that is still 19. And you have the same answer. Easy, right? Okay, now let us go to the third example. We have this application again for the theorem number 1. So, we have arc KN is equal to 215 degrees, while arc LM is equal to 7x minus 44. And the chords KN and LM are congruent. If that is the case, remember the theorem number 1 states that if your chords are congruent, then you will also have intercepted arcs that are congruent. So, if this is the case and you are asked for the measurement of arc LM, then basically you don't need to solve the problem, because if this is already given as 215, then this arc is also equal to 215 degrees. Easy, right? But if you're asked what is the value of x, then basically what you can do is you just equate the 7x minus 44 to 215 and then solve for the value of x. So you transpose the 44, giving you 7x is equal to 215 plus 44. If that's the case, then you simplify that 7x, 215 plus 44, that will become 259. Okay, and then you divide both sides by 7. So that gives you x. So 25 divided by 7, that is 3. You still have a remainder of 4, 49. And 49 divided by 7 is 7. Therefore, the value of x is 37. Easy, right? Now, let us go to our final example. We have here a square is inscribed in circle Z. Now, the question is, if arc TW is equal to 5x and arc UV is equal to 6x minus 18, then what is the measurement of arc UV and what is the measurement of arc WTU? Now, if this is a square, basically, the arc here, the arcs here, the arc here, and the arc here are congruent. Why? Because if these chords are congruent, then the arcs are also congruent. So we will equate arc UV to arc TW. So that is arc TW is equal to arc UV. So that will become 5x is equal to 6x minus 18. And then you solve for the value of x. So you can transpose the 6. That will give you 5x minus 6x is equal to negative 18. That will give you negative x is equal to negative 18. Divide both sides by negative 1. Therefore, the value of your x is positive 18. Now, if this is 18, 18 times 5, that is equal to 90 degrees. If that is the case, then this UV here is also 90 degrees. Now, we have already answered the measurement of arc UV. How about arc WTU? Now, since arc WTU is a sum of two congruent arcs, then if this is 90 and this is also 90, of course this is 90, then we can say that WTU is equal to 180 degrees. And you have answered your problem by just applying the theorems that you have learned earlier in this discussion. So basically, it's so very easy, my dear math learner, on the relationship of arcs and chords. Now, this is the time that I will challenge you whether you have understood our topic, and here it is. Okay, math learners, I hope you have a wonderful time about our discussion for today. This is still your free access math teacher, Ash. And always remember, it is fun to learn mathematics if we are together learning. If you do have some questions, inquiries about our topics, then just put your inquiries in our comment section below. Thank you for subscribing, liking this video, and sharing this to your fellow friends, classmates, and schoolmates. God bless, take care, and keep safe always. Congratulations, math learners, for arriving to this part of the video. If you think that this video have helped you, click that like button. And if you think that this channel can change the way you see mathematics, do not forget to click that subscribe button and notification bell. Thank you.